So this is our first actual calculus lesson, and we're going to be talking about how to find limits graphically. So graphically is like the probably the easiest way to find limits, but it doesn't always work so great. If we don't have a graphing calculator, we're not going to be able to find the limits graphically. So we first want to start off by talking about what is a limit. A limit is the y value a function approaches from both the left and right side of a given x value. So the limit's going to be this y value a function is going to get closer and closer to from both the left and the right side of a given x value. Here's what's weird about limits. It doesn't have to be exactly what you would think it would be. Like, we don't have to have an exact value there to have a limit. On this one, we have a parabola, and it's a continuous function. Continuous functions, it's very simple to find the limits. In fact, in this one, if we find f of negative 3, what's the answer to f of negative 3? 4. Now it's asking for the limit as x approaches 3 of the function. So here's what it means. As we approach negative 3 rather, as we approach negative 3 from both the left and the right, what is the y value we're approaching? 4. That's our first limit right there. So in this case, the limit is the same as the y value right there. And that makes sense, right? Well, look at this one, f of negative 3. If I go to negative 3, look at the y value. There's an open dot. So what that means then is f of negative 3 is undefined. There's no value there. So we called it that f of negative 3. It doesn't have a value because there's an open dot. But what gets a little confusing is that there is a limit, because the limit is defined as the y value that we're approaching as we get closer and closer to negative 3. So what is that y value we're approaching? 4. So the limit is still 4 even if we have that open dot there, because the limit is just the y value we're getting closer and closer to. I always think of this as like if there's a pothole in the road. If this represented the road, you would keep driving. Just because there's a pothole there, it doesn't mean that you have to stop completely, right? You could just avoid it. So the value that we're getting closer and closer to is still going to be 4. Now, this picture would be like we have a pothole here, and maybe that asphalt has been thrown over here, okay? Just giving you kind of an analogy of what this is like. In this case, f of negative 3 is right there. So what is that y value when x is negative 3? 1. But the limit just means what are we approaching? So we're still approaching this point. So the limit here as x approaches negative 3 is still going to be 4. All right? That's what's confusing to people, I think, is this case. Is because we've got this value here and you think, well, isn't the limit equal to that value? No. A limit is just telling you the tendency of the graph. All right, let's look at this one. F of negative 3. What's that going to be again? 1. Now, it's asking for the limit as x approaches 3 of the function. Well, in order to have a limit, as I get closer and closer from the left, I have to have the same answer as when I get closer and closer from the right. Well, we're not approaching the same point, are we? If we think of this as our road again, if I'm driving on this road, I would have to come to a complete stop. There's a pothole there and there's no continuation after it. And if we were driving on this road, we would come down to here. So these would never meet. So therefore, when we have a situation like this, we say the limit does not exist. And you can just put D and E for that. The limit does not exist. On this example, they're asking us f of negative 3. That means when x is negative 3, what's y? You can see that that answer now is going to be 2. But still, this general limit, this is called a general limit. As we get closer and closer from the left and from the right, are we approaching the same y value? No. So this limit does not exist either. All right, now here is the exact math definition for a limit. So this is the way some of your calculus classes might start next year on day 1. They may say, given a function f, the limit of the function as x approaches c is a real number r if f of x can be made arbitrarily close to r by taking x sufficiently close to c, that's the value we're getting closer and closer to, but not necessarily equal to c. If the limit exists and is a real number, then the common notation is the limit of the function as x approaches c equals that number r. Okay? So that's the formal definition of a limit. We can also have a one-sided limit. These limits back here are called general. The reason they're called general limits is because we're just approaching the number. But we can also approach the number from just one side. A one-sided limit is going to be the y value a function approaches as you approach a given x value from either the left or right side. So a one-sided limit is going to be asking us, what is the y value we're getting closer and closer to? Now these will not be does not exist. We're going to have answers on these. See, look at this one. This is saying what's the limit of the function as x approaches 3 from the negative side. I go to 3. The negative side of 3 is over on the left. So this can also be thought of as the limit of f as x approaches 3 from the left side. And do you see why that's going to be -1 as we approach from the left? That's -1. As we approach 3 from the right, though, we're going to be approaching 2. So we have an answer for this left-sided limit. We have an answer for the right-sided limit. But what would we say about the general limit as x approaches 3? What did we say about the general limit in this situation? Does not exist. Okay? All right. Let's try some problems. So I want you guys to take a look at this picture that we have, this graph, and I want you to try to answer these questions. You can either work alone or with your partner. You guys can scoot back if you want. So I'll give you another minute and a half. I want you to try to answer each of these. All right, let's start answering these. What do you have for A? As we approach -2 from the left, what did you put? 1, good. As you approach negative 2 from the right, what do you have? Negative 2 is correct. What is the general limit then? Does not exist. Those must be the same in order for us to have that general limit. Okay, what about as we approach 1? What's the limit as we approach 1? What's the answer to that, guys? 1. The limit as x approaches 0. What's the y value we're approaching as we approach an x value of 0? Negative 2, good. Okay, as we approach 3 from the negative side, here's 3. We're going to approach it from the negative side, and you should have gotten 5. This is asking for the general limit as we approach negative 1. Here's negative 1. The general limit as we approach negative 1 is going to be negative 3. Now we're going to talk about the general limit as x approaches negative 3. Here's negative 3. As we get closer and closer to negative 3 from both sides, you should have had 0. And then finally, f of negative 2. If I go to negative 2, f of negative 2 is going to be where that closed dot is. That's going to be 1. But what's f of 1? Negative 2, right? So that limit as x approaches 1 is actually 1, even though that y value is different. All right, the 3 cases when a limit does not exist. The first case is going to be when the left and right sided limits are different. That's what we had up here, right in this place. You can also think of that as a gap. Whenever we have that big jump or that big gap right there, that is not going to have a limit. Another case is when we have unbounded behavior. Unbounded behavior means that the function is just going way up or way down. When does that happen? When does a function go way up or way down? When it approaches a what? Vertical asymptote. Good. So if I had a function that say it's approaching 0 and it goes like that, as it approaches 0, it's going way up to infinity, so we would say that that limit does not exist. Because by definition, a limit has to approach a real number. This last case is called oscillating behavior. Sometimes we have functions that just go, they're kind of general like this, and then as they get closer and closer to 0, they start jumping all over the place. So when that happens, we're not going to have a limit because that function isn't approaching one specific number. It's just, the behavior right there is not going to be a constant kind of change. We can find a limit here, 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 but when we have that oscillating, no. All right, sketch a graph of a function g that satisfies all of the following conditions. G of 3 has to be negative 1. That's telling me that when I have 3, I have to have a closed dot at negative 1. The limit as x approaches 3, though, is going to have to be 4. So the limit as x approaches 3 is going to have to be 4. So if we have to approach 4, I have to have an open dot there. Why can't I have a closed dot here and a closed dot here? It would not be a function anymore. Okay? So I need for this limit to be 4. I can make this go off any way I want. I might want to read some more before I actually make that decision. The limit as x approaches negative 2 from the positive side is 1. As the limit as x approaches negative 2 from the positive side has to be 1. I don't know for sure if this needs to be an open or closed dot yet, so I'm going to just leave it open for now. I might be able to close it here in a minute. The function has to be increasing from x being negative 2 to x being 3. So negative 2 to 3, it has to be increasing. So like that. The limit as x approaches 2 from the negative side has to be greater than the limit as x approaches negative 2 from the positive side. All right, let's look at this. So the limit as x approaches negative 2 from the negative side must be greater than the limit as x approaches negative 2 from the positive side. So this right here is going to have a limit answer of 1, but this one has to be greater. So where should I put my dot, above or below? Above this, right? I can put it anywhere above it. It doesn't tell me specifically. I'll just put it right there. And I can use a closed dot since I used an open dot there. If I used a closed dot there, I have to use an open dot there. Those are all the requirements I have to meet. And so now I'm just going to connect to make it a function. I can make this one go any way I want. Doesn't matter. So that would be one example that meets all the requirements. G of 3, just double checking, G of 3 has to be negative 1. The limit as we approach 3 has to be equal to 4. Hold on a minute. Does that just say the limit is... Oh, that's not going to work, is it? Anybody know why that doesn't work? Right now, do I have a limit as x approaches 3? No, I don't, because I have a gap there. So I'm going to have to change that. Here's what I'm going to have to do for this. So it told me right here that G of 3 had to be negative 1, but because that limit has to be 4, I have to have a closed dot here, but I'm going to have to make the function go like this to meet all the requirements. So when you're doing one of these, you need to go back through and double check. I'm going to check everything. G of 3 is negative 1. The limit as we approach 3 is 4. That's good. The limit as we approach negative 2 from the right has to be 1. G has to be increasing from negative 2 to 3. The limit as we approach negative 2 from the left has to be greater than from the right. Okay, now it works. So sometimes you're going to graph these guys and you're going to have to go back and make some changes. All right. Let's answer these as true or false. The limit as x approaches negative 1 from the positive side is 1. What do you think? True or false? True. Good. The limit as x approaches 2, the general limit, as x approaches 2 is 2. Yep, true. The limit as x approaches 1, here's 1, from the negative side is 1. Agree? True. The limit as x approaches 1 from the positive side is 2. Agree? From the negative side means from the less than side. So right here, the value I'm approaching is 1, so from the negative side means from the left side. Negative means from the numbers less than. And then this is the numbers as we approach 1 from the positive side means from the positive side of x. So these numbers are greater. So do we agree this one's true? Yes. Okay, what about the limit as x approaches 1? Is it true that it does not exist? Yes, that's true, right? It does not exist. That's true. Because, guys, look, as I approach from the left, it's 1. As I approach from the right, it's 2. So if we have that big gap there, or a jump, as some books call it, that's going to mean that we do not have a limit because we're not approaching the same value. Okay? And then the limit as we approach 0 from the left side is equal to the limit as we approach 0 from the right side. Do you agree that those two are equal? Yes, true. Okay, and then lastly, the limit as x approaches 2 does not exist. True or false? False. False, that does exist. What is that limit? It's 2. We already said it, right? All right, do limits kind of make sense to you? No. No? What part of it does not? Okay. All right, so you need some more practice. There's a worksheet on there that you can practice with, and I'll also post the solution so you can check as you go. But yeah, this is where calculus always starts, is with these graphical limits to look at.